First of all, thank you all for joining this session and giving me some of your time. Today I'm going to talk a little bit about indexing your query, which is kind of funny, right? We all know you can't index a query, you index a table. But if you follow along with my methodology, that's the big takeaway that I want you to have today, is my thought process, how to really kind of take a step back from looking at things in a problematic query way and looking at it more at an aggregate workload way. Okay. Part of the process, hopefully, that you'll get out of this is how to move to more of a reactive mode than a proactive. You know, that's something that we talk about a lot. That's a lot of vendors say this is how we can do it with products and stuff like that. But how do we really execute on that? And how can we do that from a tuning and optimizing standpoint? Again, looking at workload more holistically can really help us start to achieve this instead of being reactive to, oh, my bad query, right? I'm hoping that this gives you some information to really start rethinking about how you view your workload within your environments, and hopefully give you guys some information to help you look good within your current positions. Okay, so how do we do this? How do we do this? Hang on. There we go. Okay. So if you're like me, and this is kind of from a traditional perspective, right? I would be very reactive. Common practice, find the biggest, baddest query, see what kind of resources it's consuming, see if it's got a good plan, stuff like that, see if it can use some tuning, and then go from there, right? So finding the biggest needle in the haystack is what I call it. At times, it can come down to many different potential fixes for a given query, but a lot of times it does come down to indexing strategy, and that's what I want to focus on a little bit today, thus the title. The other thing that I used to fall into as a bit of a trap was I would add my indexes without any awareness of what impact that had for other workload. It might fix that one query, but did it hurt transactional DML, right? Did it help other queries, right? Hope is a strategy, maybe not a good one, but it is a strategy. Okay, so again, my big takeaway, the methodology, my thought process in this whole thing. Okay, evolution 1. This is where I started. This gets a little bit of an eye chart, but here's a query that I started with to go after query statistics, right? So you can see I'm going after, DM exec query stats, DM exec SQL text. That's just for convenience. Could have stuck with the SQL handle, but decided I wanted a little snippet of what the text actually was. Again, this is where I started, and you can see, if you want to, at the very bottom, I was actually ordering by total logical reads divided by execution count. So how many total logical reads divided by the number of times this thing ran. And I was like, this kind of bothered me a little bit. Like I didn't quite land where I wanted to. There's a whole bunch of different things I kind of threw into the basket just to kind of see what data I could pull. And again, wasn't totally happy. I was missing something, right? So after many iterations of this and just, trial and error, I actually landed on this. And probably the simplest way to do it is if you look at the very start of the select clause and what I define as my inefficiency factor or inefficiency here, this is what I became a lot more happy with. So my thought process was, what is the amount of work that SQL Server is having to do to answer this query, right? So I've got my logical reads and physical reads, divided by now the total rows, not the executions. So how many rows was it looking to process? So how much work, what reward, right? And then I landed on execution count as a multiplier, because this thing should be penalized the more time it runs. Make sense? Cool. So basically what I'm looking for is Low ROI queries. A lot of work, small reward. Cool. So this is where I did end up, and I'm going to go through a little bit of my, excuse the graphics, they're not very good. So the concept here, though, is that I want to look at this large subset of SQL, and then I want to put it through this colander, this filter, and then find the ones that I want to focus on or should focus on. But do it more systemically, right? Don't worry about the biggest one needle in the haystack. Look for a bunch of needles in the haystack that are related. Okay, so after sifting through my workload, I've got my queries. They're now ranked from worst to not so worst by my definition, and I'll get to what that is in just a minute. What I would say, where I landed was from a kind of holistic workload perspective. You guys may differ. So it kind of depends on, what resources are you most constrained by in your environments? That might be the statistic you want to focus on from a query perspective, okay? So my ranking may be a little bit different than yours, but no worries, it's the methodology. You guys can land, kind of what's appropriate for your environment. Let's see. Of course, do not focus on the long tail of the queries, and I'm going to show you how I did my cutoff to start with. And as far as, you could pull back, depending on your environment, you could actually pull back a ton of different SQL statements, right? So you might want to limit that. I'll actually show you how I began to filter once I started doing this. And again, these are the queries that I probably should be focused on. So I do. Okay. Why do these queries suck? It might be a US expression, so excuse me. But what's wrong with this query? Why is it a problem? Right? There could be many reasons why a query is inefficient. Could be there's a function in the where clause that's not accommodated by the index. Could be an implicit data type conversion, so your optimizer can't work with an existing index. Could be code explicitly doing a data type conversion, right? I've actually seen that. Not a good, best practice, but I've seen it. Statistics could be bad or stale. The optimizer doesn't have good stats to work from to make good decisions. What are the high-cost plan steps? Is my table too large, too wide? Comes down to a data modeling issue. The next one, and this is kind of an interesting one, I'm not going to dive into this one too much, but the data skew. Do you guys know the data skew in your problematic objects? Yeah, I don't think most of us do, especially for the columns that are indexed, right? Are those good candidates? Is there high cardinality in the data skew? Or is there low cardinality? Higher cardinality, better candidate for indexing. And then that kind of gets into the last one, are my indexes optimized? And that's what we're going to talk about today. Okay, different views, and you guys don't have to, worry about this. I just kind of threw them up there in case anybody wanted to know, like, what are some of the DMVs that I went against and started to do my investigation against. Okay. Oh, I think one thing to note, sorry, and I'm looking at my notes to make sure I don't forget anything. I started to group my queries by object, okay? And the cool thing then is that I can look at the workload actually hitting certain tables to see what the result was. Okay. So, what is bad? Seems like that's a kind of subjective statement, right? Bad for me may not be bad for you. What's important to you? Again, you guys can start to filter on probably what's most constraining within your environments, but I think holistically, this is probably the right answer for 90% of the use cases. I started to look at this reads to rows ratio, so we'll start there, right? This read inefficiency. I had to read all these pages, a lot of pages, and if you actually look at some of the plans out there, it can be millions, tens of millions of read operations for how many rows desired. That could be single digit. That's a bad, bad ratio in my definition for sure. So I was looking at this ratio, total reads to total rows, and I said that for me that has to be greater than 8. So why 8? It's my lucky number. So you guys choose yours, insert here. So for a set of queries, the number of page reads to the number of rows desired has to be greater than 8 for me to consider within my algorithm, within my methodology. By the way, if you do this and you come back with like 1 row per object or something like that, like 1 query per object, maybe adjust, maybe get a little less sensitive. If you come back with way too large of a work set, raise the bar, right? Tuning and optimizing can be and should be very iterative in nature. Okay, so we're going to go through this, tackle the first one, tackle the most egregious within your environments. And then once you solve for that, move on. Okay, again, what is bad? This is totally just a reminder that just the relationship between pages and rows. So within a page, and that's why I have this, simplistic kind of diagram up here. But within a page, you can have multiple rows, right? Many, many rows, depending on, row size, fill factor, things like that. But anyway, the big thing to state here is that my inefficiency score that I calculated is actually probably off by an order of magnitude or 2 orders of magnitude or something, right? Because I'm looking at page reads versus rows desired. So it's way worse than 8, let's say in my case. Okay, an example of, and this is just like mock data, so bear with it, but it illustrates the point. So now that I have the data grouped by table, and you can note here they're all on order line item, notice the total reads. They're actually the same for every query that I captured, right? So number one, that's kind of telling to me. Also note, the first query has a very high execution count. So, and again, I'm going to penalize that query because of that execution count, right? I'm going to make sure that it gets raised up because a query that executes 1,000,000 times should be considered worse if it's inefficient than a query that executes 1 time. Okay, and then the last query, you can see that it did the same number of reads, but the thing is, the rows desired was actually pretty high. So my ratio is like 1.6. The point here is that SQL Server would have had to do the work anyway to get the answer, right? So unless I change my query entirely, there's not really anything I can do to help that thing. It's probably already as efficient as it's going to be. The other thing to mention is that the query stats that I was grabbing are cumulative. So you have to kind of do 2 periods of time and then do the diff between those 2 data sets, right? So whatever's right for you, whatever you want to say is my representative kind of workload, like let's say Monday to Monday to get a full week, a full month, Monday to Friday, whatever's right for you guys' environment. So, but it'll give you kind of the T0 and then T1, and then we can compare the stats. Okay, another thing that I looked for during my investigation was plan advice. What does SQL Server have to say? Not what do I have to say. What does the vendor have to say about this? Are they observing any missing index advice, right? This will be in the query plans, if there is some. Now, who here implements every single SQL Server index recommendation that they have? Blindly. Yes, good. Perfect. Me too. No, not really. But usually what I say is that, look, it can be, it's not always wrong, by the way. So, no, I never trust that. It's like, I don't know, it could be directionally correct, right? So should be considered, should be part of the factor in. It's another indicator that I'm going in the right direction. But yeah, we want to independently validate that that is the right direction. Inspecting the query plan. So because of those index recommendations, I would actually expect to see, some kind of table scan. You look at the operator involved, that's not what I want to see. It's not going after it in an indexed fashion. So definitely not the plan I wanted to see. Again, kind of points to that index advice. Maybe not a bad idea. Who here knows what I mean when I say producing versus consuming steps in a plan? Oh, new concept, cool, right on. So to me, a consuming step is like an aggregator, a sort operator, nested join, inner join, any kind of join. The producing steps are the things that are actually fetching the data. Things like table scans, index seeks, right? Those are the producing steps. The problem is if you look at a plan and you only start to look at the high cost operators, if they are consuming steps, the only way to help them is to reduce the feed from the producing step, right? Maybe get it to do it in a certain order as well, but I'm focused on the data feed. If it's a lot of data flowing into that aggregator or that consuming step, you got to look upstream. Cool. The other thing you might want to do is inspect the query plan for kind of warnings, right? SQL Server will insert into the query plan certain things that are happening that you should probably be paying attention to. Some of those things are implicit conversions, right? Those are always, nobody likes those. Happens though, quite a bit. Any kind of parallelism, does that surprise you? You're like, why wouldn't I want my execution to be parallel? Okay, parallel executions can actually be an indicator of huge amounts of data being sought, right? That's why it's important. So if I can reduce the amount of data being sought, I'm not going to hit that cost threshold for DOP, and thus it's not going to push into a parallel execution. Again, just an indicator. Not all parallel executions are bad, by the way. Spooling, whether it be lazy or eager. So again, another indicator that, Optimizer thinks it might need to save this data for later, and it already did all this work, so it's going to go ahead and spool it to temp. Key lookups. Who thinks key lookups are bad? Anybody? Yeah, good. Okay. What's that? It does depend, but generally speaking, like in a lot of times, a key lookup is because I've defined my indexed columns, but I don't necessarily have my included columns correct. It's not a covering index. It found the shortcut via the indexed columns, but then it also had to go read the table, which can cause almost 2x I/O, right? Sometimes more. Okay, so real quick, I'm going to pause there and do a sanity check, right? So, got some check marks here. This query popped up in my sorting algorithm, right? It got through the colander, the filter, if you will. Met my reads to rows ratio, right? So I set a boundary, had to be greater than 8. These things popped up. Has an index recommendation. May not have, but in my case it did. So I'm like, okay, that's another +1 in the pro column. Pretty cool. And when I inspected the plan, it's doing a full table scan. So again, kind of all these things are kind of leading in the same direction, right? All kind of validating each other. Okay, so my next step anyway was to go through and see, what is my current indexing strategy? Did I have an index that might have been able to be used, right, for these missing indexes? So upon further inspection, I did not have an index that could have been used. Now, the reason I want to check and make sure is that sometimes you can have an index, the optimizer just chose not to use said index, right? That's a black box. Can't really do much about that, other than make sure you got good stats and stuff like that. You can use, who uses hints? Anybody use hints? I don't like them. No, I know sometimes you have to, but that's kind of like forcing the optimizer, hey, you're being bad, make better choices. Sounds like I'm talking to my teenagers. They don't listen either, so. So I check my indexes. Again, nothing there that the optimizer could have used. So in this case, I'm clear, right? I know that I didn't give the optimizer anything to use within my data model. Okay, I think that's good. Oh, one other thing real quick to mention is, while doing this investigation, I also kind of threw in, like, look for duplicate indexes, like multiple indexes that could have been solved with just one. Because if it's a highly transactional table, and I'll get to that in a minute, there's overhead for carrying that index. Every time one of the columns defined within that index changes, the data within it, that has to be maintained as well. So you're actually adding an anchor to your workload through over-indexing or having too many. And certainly if you have duplicate indexes, that's something to go ahead and get rid of. Indexes that are used versus not used. So another query that actually goes right against SQL Server and says, hey, when were you last used? Is it used frequently? Now, this can be used against the indexes. Now, be careful a little bit, though, because when you run this, be on the lookout for cyclical patterns, because just because an index wasn't used today for whatever 15 days prior doesn't mean it wasn't used for end-of-month billing, right? The end of February, end of months, end of quarters, end of year. So some indexes may not be frequently used on purpose because they're there for a reason, for like reporting purposes or something. So just be aware of those cyclical patterns. What I would say is kind of test it periodically and see what you get, but then put it on a list and then go back and check later and make sure it's still not being used. But anyway, this can help you identify, I've got indexes. They're not duplicate, but the optimizer's not using it either. So why am I carrying it? Okay, and this is something that I was going to reference. Quick time check. I think I'm going to get done pretty quick here. Data churn. Why do I care about data churn? Again, if I'm adding indexes, we already covered the concept or whatever that there's this carrying cost. There's this overhead associated with my indexes. So it's important to understand, if I'm going to index a table, what is the data set in that table and how does it change over time? If it tends to be very static data, index the heck out of it. All it costs is storage, right? Storage is cheap now. If it's highly transactional data within the table, you definitely have to be more careful about indexing. So this query will let you know, and again, kind of periodically, compare it over time, how much is the data changing within this table. So at least in my opinion, it's a pretty good proxy to say, what's going to be the cost of adding an index, or maybe the savings of getting rid of an index, right? Now, what's bad, what's good, it's subjective. I can tell you my thoughts. If I see data churn of more than 50% in a day, like a 24-hour period, I'm going to start to get a little bit cautious with my indexing. I'm going to definitely make sure I'm not over-indexed, but it might not prevent me from adding a new index if I really think it'll help the workload. So if it gets to 100% data churn, that's pretty high. That means all the data in this, this table changed, which, by the way, it can easily be over 100%, right, for highly transactional type tables. So if I get to there, I'm very cautious with my indexing strategy. But anyway, this query can help you get to the answer there. So what should I do now? Rinse and repeat, right? Who here has a completely static environment? Right, nothing ever changes, right? Would love to live in that world. Tune it once and be done. No, we don't do that. We don't have that luxury. So everything's dynamic in nature. We're constantly upgrading, changing, modifying, pushing new code, upgrading third-party vendor application, upgrading the SQL Server, binaries themselves, introducing new storage, maybe different resources, maybe throwing more CPU at it, maybe more memory, things like that. Statistics of the data themselves within the table, constantly changing, right? And we're hopefully capturing that on a fairly regular basis, especially if it's very dynamic data. So as things change, as things become more dynamic, hey, it's job security, right? Not a bad thing. What I would say is measure your success. So I went through the methodology. We kind of looked at how you identify the inefficient workload, right? From I'll call it a read efficiency standpoint. Once we do that, whatever changes you make, I'm hoping you capture, right? You should be rewarded for that. You should be recognized for that. So measure your success. What impacts did you have? And by the way, you also have a great gauge now of, hey, I found this index, or through my analysis, through my methodology, I found this index that really is needed. And I didn't just fix this one query. I fixed a whole bunch. Right? If I go back to that Excel spreadsheet that we looked at earlier, you're going to fix a whole bunch of workload. That's going to have a huge impact. And the big thing to remember is all these things are connected, right? If I'm constantly having to read pages because my data model, my indexing strategy is inefficient, that essentially gets pinned in cache. That's memory addresses that could be used by other workload. So now I'm causing potentially I/O, right? Got to go back to the storage. That's going to be an order of magnitude worse, even if you have SSDs. So, the point is you're not just fixing one thing, you might be fixing a whole bunch of things that otherwise might be an issue. Sorry, one quick question, thank you. Let's see. When would you advise to disable and rebuild index as part of ETL? Haha, great question. I have another session tomorrow about why are we rebuilding and reorganizing our indexes. I'm going to put that one on hold if you will, Kim, but I'll give the classic DBA answer, right? It depends. So, sidebar, okay? Who understands the difference between external and internal fragmentation of indexes? Perfect. Yep. It's kind of like physical and logical, right? I'm not worried about physical fragmentation anymore. I'm more concerned about the logical side of the house. And a lot of that comes down to modern disk architecture. Again, don't want to get too deep into that one, but feel free to join me tomorrow. And it's going to be a 20-minute talk, so I won't bore you this much. Let's see. Is there a link to download session material? I think there is. I think I have to upload this to Sessionize or something like that, and then it will be available through SQL Bits. We'll find out. I'll get you an answer on that one. I'm not sure. Okay. Any other questions from the room while we're on it? Cool. Okay. Again, all the resources are connected, right? If we have to go from cache to disk, that takes CPU cycles. The cache that I'm already using or consuming could be used by other workload. Again, it's all connected, right? We want to fix all of our workload. And especially, yeah, this one's a good point here. Who here has a cloud migration strategy? None of you has any workload in Azure or AWS. One? Okay. What's that?
If I'm only in Asia, then I don't need a migration strategy.
If you're only in Asia, are you on-prem or? Oh, Azure. Oh, yeah. No, you're already there. Yeah. Sorry. You're probably not the normal, right? And I don't mean that personally, but your data residency is probably abnormal from the norm. Most use cases, what I see now are there's a lot of companies that are coming from on-prem, and now they either have a cloud strategy or they're in the process of migrating some of the data. And then some goes into cloud, some comes back out of cloud. But that's a different story too. All right, so this becomes especially important to cloud strategies because guess what? Your company is now paying for that cloud compute, right? The size or the tier of the instance, whether it be Azure Managed Instance or Azure SQL DB, or you're leveraging VMs out there, your company is now paying for those resources. So, and by the way, if you touch any of the bounding boxes within that tier definition, you get throttled. Unless you have like bursting, but then you're spending more money. So you have a choice. Your company can keep spending, throwing the credit card at the problem, or you can actually look at tuning the queries themselves, reduce the pressure on those resources. That's true green, well, I say green dollars, but I don't know, what's the color of the euro or the pound? I don't know, but it's cost savings, right? And therefore, you're a cost benefit to your company now. You guys can have an ROI. That's pretty cool. Okay, again, to stress, rinse and repeat. None of us works in a static environment. Things are always changing. As these things change, as you guys help your company save money, as you help the workload be more efficient. By the way, this whole methodology is usually okay for both in-house developed applications as well as third-party vendor apps. Now, I would say work with your vendor. Don't just start throwing indexes out there, right? But work with your vendor to make sure that it's okay, but you're not changing their source code or anything. You're just making it more efficient. So usually vendors are pretty cool with it, and you guys can charge back some consulting fees. So that's pretty cool. Okay, one thing that I've learned for sure is, and by the way, this is so you guys can give feedback while I kind of wrap up here, which I appreciate, by the way. When I've done data modeling and SQL development, rarely has my understanding of how end users will interact with the data set been true to reality. You sit in the planning meetings. You start to do your data modeling, your design. If anybody's done that, by the way, it's pretty cool if you have. You start to build out your data model, your ERD, right? And then you start to, normalize things to a certain degree, right? We can all agree to disagree on the correct normalization number. But as I did that, and then because I used to be the developer and the production DBA, so I had to live with my own code. I'd be like, wow, developer Rob really sucks. So as I did that, though, it became very interesting that what I was told this application was going to do, or what the end users were going to do with the application that was accessing my data model, rarely came to fruition. So going back, inspecting, making sure you know what the workload actually looks like when hitting your data model, that's pretty cool. Okay. Any other questions? Yeah. Oh.
In your consideration of which indexes to use, etc., when you're analyzing last time used, etc., would you consider the index size as well compared to table size?
Can you repeat that in English? No, I'm just kidding. Don't. Can you say that again, please?
When you were analyzing the indexes,
Yeah.
and you look at for the last time it was used, etc., would you consider the index size itself compared to table sizes?
That's going to depend, right? I mean, the index size is going to be dependent on which columns are actually included as being indexed, and then how many are being included within that index, because that has to be held as well. I wouldn't necessarily take that into consideration. No, I mean you might, but again, storage isn't an issue anymore.
Yes, but for example, if your index is it's 1 gigabyte, right?
Mm-hmm.
And your table is 1.2 gigabytes. Is it equivalent to use? Is there a ratio between them?
Not that I've ever found. No. The only thing that I would say is that'd be a pretty wide index, right? I mean, if you've got whatever 10 columns, you just included 9 of them. So I'd be a little careful with that. Indexes weren't intended to be that, like a replication of the table. So. Yeah.
You haven't mentioned anything about that part, because deleting is, for me, often the worst part, because I'm blocking.
Yeah, no, that's a great comment there. So this talk wasn't meant to really go into the locking and blocking aspects of it, or the contention of concurrent access to the same resource, whether it be a table, a row, or like an index, like you say, from any kind of DML operation. It is hugely important to understand if things that you've introduced are actually causing contention like that. What I've been talking about is more physical resources, in the sense of CPU, memory, disk I/O, things like that. But that's very true that the data itself and the objects that we create within our database model, those are resources also, just in a different fashion. So I really didn't speak on that, but if you want to talk more on that, I've got some pretty awesome thoughts about that as well that I'm happy to share with you.
I think you had an interesting point on measuring your success, because we often see this as when everything runs, it's invisible.
Right.
And when it's not running, it's not invisible. And you have to commit yourself that this is better than yesterday. And then you need some figures to see, I'm convinced that you can present it to your manager as well.
And being,
As long as he's not hearing anything.
yeah, and be empirical about it too. Being able to measure your success with numbers instead of, hey, I made things better. Now you can actually point to improvements by re-inspecting the plans, by doing this kind of strategy. But you are correct in one thing, and that's for sure, and that's the best DBA is the one you don't know you have. So, yeah, it sucks when we get in the hot seat, but yeah. Oh, I don't see it. Is it in?
The question is,
Oh.
how much are you using column store indexes?
How much am I using column store indexes? So I did not take that into factor either because I wanted this to be a little more, is that still in there? Yeah. I wanted this discussion to be a little more agnostic than things that are dependent in different versions that you guys might be leveraging. So this is a more holistic approach. It can definitely be impacted by column store indexes and such. So yeah, not necessarily a factor in this discussion. All right, guys. Well, thank you very much. Really appreciate it.